Okay, so we're going to look at solving the trig equations with a real world situation. So first, remember that inverse cosine is only defined in quadrant 1 and quadrant 2, and inverse sine and inverse tangent are defined in quadrant 1 and quadrant 4. So that means if we were just going to do this with our calculator, the calculator will only give us one answer, right? Either the positive or the negative, depending on where it's defined. So to get more than one answer, the easiest thing to do is to use our inverse trig to find our reference angle in quadrant 1, then use reference angles to find the solutions. So remembering our reference angle rules down here at the bottom, we know that in quadrant 1, theta equals theta hat. So if we've got a guy in quadrant 1, we're good to go. In quadrant 2, remember this angle would come all the way here. In quadrant 2, theta is pi minus theta hat. In quadrant 3, remember theta goes all the way around. In quadrant 3, theta is pi plus theta hat. And then in quadrant 4, again, we're going all the way around. That whole angle is theta. In quadrant 4, we're at 2 pi minus theta hat. So we will use our inverse trig to find our theta hat in the first quadrant, and then use these rules to find the rest. So we have a real world situation here, right? So this is the number of sunlight hours in a day. Here's my equation. They want to know during the first 365 days, when will there be 11 hours of sunlight? So if we think about what that equation would be, that means we want the number of hours of sunlight to be 11 equals 12 plus 2.9 cosine 2 pi over 365t. First, let's talk about the first 365 days. So to do that, let's look at the period of this function, right? If we look at the period is 2 pi over b, correct? So that's going to be 2 pi over 2 pi over 365, right? Which is 2 pi times 365 over 2 pi. So the period here is 365, which means we're not going to have to worry about k values in this problem. So now let's look at just that function and solving it. So the first thing I'm going to do is I'm going to rewrite it with a theta instead. So I'm going to let theta be 2 pi over 365t. Okay, that's the first thing we're going to do. So now let's rewrite our function, and we want to get it all simplified, right? So if I subtracted 12 from both sides, I'd have negative 1 is 2.9 cosine theta. And if I keep going, I would have that the cosine of theta is negative 1 over 2.9, right? So let's think about that for just a second. Cosine is negative on the left-hand side of our Cartesian plane, right? In quadrant 2 and quadrant 3. So we could put this in the calculator and get the guy in quadrant 2, and then we would have to figure out what theta hat was to get our quadrant 3 guy. So the easier thing to do is to start by finding our theta hat, our reference angle. And so our reference angle is the positive, right? Is the inverse cosine of 1 over 2.9. That's the positive guy. So then what that means is in quadrant 2, we know that theta is pi minus theta hat, which is pi minus the inverse cosine of 1 over 2.9. And we know that in quadrant 3, theta is pi plus theta hat, which in this case is pi plus the inverse cosine of 1 over 2.9. So you could, I mentioned, or I didn't mention it, but it was on that other slide, that you could use the store and recall feature in the ALEKS calculator. So you can type in the inverse cosine of 1 over 2.9 and store it if you don't want to type it in every time. But before we can move on here, we made a substitution with theta, right? Where we said it was that theta was 2 pi over 365t. So let's look at that substitution here. So we said that theta was pi minus the inverse cosine of 1 over 2.9. And we replaced that. Theta is 2 pi over 365t is pi minus the inverse cosine of 1 over 2.9. So to solve that for t, I need to multiply both sides by 365 over 2 pi, right, by the reciprocal. So the first time that I'm looking at here is going to be pi minus the inverse cosine of 1 over 2.9, that whole thing times 365 over 2 pi. That'll be my first time. Now, looking at my quadrant 3 guy and making that replacement for theta, we have 2 pi over 365t is pi plus the inverse cosine of 1 over 2.9. So for t, again, I'm going to multiply both sides by the reciprocal. Pi plus the inverse cosine of 1 over 2.9. All of that times the 365 over 2 pi. Okay? And again, I'm not going to take the time to put it into my calculator right now just for time's sake, but you can see that if you use the recall function, you would just be doing pi minus your recall, right? If you used inverse cosine of 1 over 2.9 and stored it, and then find that answer and multiply it by 365 over 2 pi. Let's look at another one. So here we have an airplane, and it's in a holding pattern near an airport. We say, when will the plane be 110 miles from the airport? So if I'm going to write the function here, I'm going to have 110 as I write 111. 110 is 142 plus 70 times the sine of pi over 5t. So that's what we're going to be starting with. And then it says during the first 10 minutes. So again, let's kind of look at the period and see if we're going to need to mess with k values or not. So the period would be 2 pi over 5, which is 2 pi times 5 over pi. And those pi's are going to cancel, and I'm left with 10. So whatever answers I'm dealing with will occur within the period, right, within the first 10 minutes. So we don't need to worry about the k values. Okay, so now let's look at making this a little bit prettier. So let's go ahead and make the substitution, and we're going to let theta be pi over 5t. So let's see, if I subtract the 142, I'm going to have negative 32 equals 70 sine theta. And then if I do that division and simplify it a little bit, I'm going to have negative 16 over 35 is the sine of theta. Okay, so sine is negative on the bottom, right, of our Cartesian plane. So in quadrant 3 and quadrant 4, right? So what we're going to do is find theta hat in quadrant 1. So my quadrant 1 guy will be the inverse sine of 16 over 35. I know the problem wants the negative, but I want the positive because that's going to give me that inverse guy in quadrant 1, right? That's going to give me that angle. So this is where you could put that in your calculator, in the Alex calculator, and tell it to store that value. So then let's talk about quadrant 3. In quadrant 3, we have theta is pi plus theta hat, right? Which means that theta is pi plus whatever the value of the inverse sine of 16 over 35 is. And if we want to, we can go ahead and make our substitution here instead of doing both angles out at the same time. So we could say that pi over 5t is pi plus the inverse sine of 16 over 35. So then to solve it for t, what do I need to do? Well, to solve it for t, I need to multiply both sides by 5 over pi. So my first time here is pi plus the inverse sine of 16 over 35 times 5 over pi. So that's the first time, and we would put that in our calculator. For the second time, we are looking in, let's see, I'll go up here, and we're looking in quadrant 4, right? In quadrant 4, theta is 2 pi minus theta hat. So that's 2 pi minus the inverse sine of 16 over 35. So we can go ahead and make the substitution now that if theta is 2 pi minus that inverse sine, then pi over 5t is 2 pi minus the inverse sine of 16 over 35. So to solve it, just like the last one, I need to do all of that and then multiply both sides by 5 over pi. So t is 2 pi minus the inverse sine of 16 over 35 times 5 over pi. And that would be your second time. Okay. Let's look at one more. Now we have a target on the ground. Let's see, it's a projectile fired from a cannon. They give me the velocity, and they want to know what angle we should use to hit a target on the ground 535 feet in front of the cannon. So we can think about what we should have here. We should have 535 equals 160 squared times the sine of 2 theta all over 32. Okay. Now, if you think about it, there's only a couple of times it's going to hit that 535, right? So we should be okay here with regard to K. So if we look at this a little bit and kind of get it down a little bit, let's see. 160 squared divided by 32 is 800. So let's rewrite this as 800. Oh, sorry. As 535 equals 800 sine 2 theta. And then let's do that division and simplify it and go ahead and make our substitution at the same time. So I'm going to let theta, now since we have a 2 theta, let's let x so we don't get confused. Let x be 2 theta. So 535 over 800 reduces to 107 over 160 is the sine of x. Okay, so this is great because this is positive, right? So the sine is positive on the top of our plane, right? In quadrant 1 and quadrant 2. And our theta hat is the inverse sine, oh, I didn't write inverse, of 107 over 160. So that's what we would put in the calculator and store, right? And nicely, in quadrant 1, theta equals theta hat. So theta is the inverse sine of 107 over 60. Maybe we should have called it x and x hat since we're not using a theta, but you know what I mean, right? So then if I make that substitution back with a 2 theta, if I have 2 theta is the inverse sine of 107 over 160. I see that. Then to find theta, I'm doing that and dividing it by 2, right? So then theta is the inverse sine of 107 over 160, just divided by 2. And then if we want to talk about quadrant 2, we know that in quadrant 2, theta is pi minus theta hat. Or again, I guess we should say x and x hat, just knowing that we're talking about the reference angle, right? So we are going to have pi minus the inverse sine of 107 over 160. But now we can make that substitution, and we have 2 theta is pi minus the inverse sine of 107 over 160. And so to solve it for theta, we just need to divide that answer by 2. So pi minus the inverse sine of 107 over 160 divided by 2. Sorry, I ran out of room there. And then you would just put that in your calculator, or again, if you went from the very beginning and put the inverse sine of 107 over 360 in your calculator and stored it. There's that store button in the Alex calculator. Then when you went to do it here, you would just hit recall, right? Recall divided by 2. And when you went to do it here, you would do parenthesis, pi minus recall, close your parenthesis, and then divide by 2. And those other 2 problems we did will work the same.